Okay, hey guys, we're back. Okay, this is problems number 6 through 10. We're going to try to get all the way through all of them. So I'm going to go a little quickly, but you should hopefully you can catch on. So number 6 is Old Faithful geyser in Yellowstone National Park shoots water hourly to a height of 40 meters. With what velocity does the water leave the ground? So to start working on this, we're just going to look at some of the formulas we can use, and we're going to look at the information we're given. So even though the 1 hour looks important, we don't really need to even know that piece of information. That's not that important. We need to know just mainly the 40 meters. So we're just going to work with this one value to get our velocity. So we know that we know our formula for potential energy, which since this has to do with height and velocity, we're going to have to use both of these, is mass times gravitational force due to acceleration multiplied by height. And we know our kinetic energy formula, half multiplied by mass multiplied by velocity squared. We know that masses cancel, so we're going to be left with gravitational force due to acceleration multiplied by height equals half velocity squared. So we're going to multiply 9.8, multiply our 40 meters, so gravitational force due to acceleration multiplied by height equals half velocity squared. We solve for velocity and we get 28 meters per second. There's your answer. Number 7. For exercise, Jennifer is walking with a speed of 1.63 meters per second. What is the magnitude of her momentum if Jennifer's weight is 583 newtons? I don't even really have to show you too much here. All you need to know is this is in kilograms times meters per second. Even if you didn't look at the answer, you should know that momentum is always in kilograms times meters per second. So that means this is a force. This is in newtons. We have to divide by 9.8 to get your mass. I hope to do a video on mass and force so that you can know how to convert and understand what the difference between mass and force is. But you have to divide by 9.8 to arrive in kilograms. Then all you're going to do is you're going to multiply that figure, whatever you get, by dividing 9.8, multiply by 1.63, and you will get your answer of 96.9. Let's see if I have it here. Yes, 1.695583. And I honestly just I solved the entire thing on my calculator. It's a very simple problem to work once you understand it. Then we have number 8, which is during a snowball fight, two balls with mass 40 kg and 60 kg, well, 0.4 kg and 0.6 kg are thrown in such a manner that they meet head-on and combine to form a single mass. The magnitude of initial velocity of each ball is 15 meters per second. What is the speed of the combined mass just after the collision? Okay, so we know that the initial velocities were 15 meters per second, so I just did a quick thing on me. So I just showed that 0.4 kgs and 0.6 kgs both equal your 15 meters per second. Then we're looking for our velocity. Let's see, I'll make sure that that's correct. We're looking for, yes, we're looking for the speed. Speed and velocity is the same thing. So we don't know what to implement when it comes to this. So actually what I'm going to do is I'm going to pull up the new notes, so this should give you a better understanding. Basically we need to know that this is an inelastic speed. First of all, you need to know what inelastic speed is. If you don't, I have a video on that. All that inelastic speed is when two objects, they may not be identical objects or of identical mass, but if either one of them is in motion, or if both are in motion and they combine at a certain point and they go in one direction and continue with that motion, then that is inelastic speed. They have to be moving. Either one has to be moving. One can be moving. Let's say this one's moving and this one's at rest, and this one collides with this one and hits this one, and they form one object and they continue in this direction. Or if this one's in motion and this one's at rest and this one hits this one and they continue in motion but they stick together as one single mass, then that is inelastic speed. So based off of the formulas from that video, we know that we can conclude that the mass multiplied by your velocity minus your mass on this side multiplied by velocity will give you two figures, which if subtracted will give you your actual velocity. Alright? So this kind of took a little bit to understand, because first of all, it's not mass times velocity equals mass times velocity. You had to understand that, yes, you had to find your momentum from this one. So actually, I'll do this to make it a little bit more understandable. Let's see if this will, maybe, yes, okay, we got it. So we need to know that P equals mass times velocity. Therefore, we can put on this side that mass times velocity is equal to mass times velocity, right? So we can say and this is if there's two different objects with two different masses. So this is when you're going to use this formula. But since we know that both masses are actually going to be combining and becoming one mass, all we're looking for, and they even ask in the problem that, well, basically, what is the difference? See, the magnitude of initial velocity of each ball is 15 meters per second. What is the speed of the combined mass just after the collision? So you're actually subtracting that initial mass. Hopefully that makes sense. Basically, what you're doing is right here, you're calculating your momentum. You're subtracting basically your momentum of one ball from the other ball to get your final velocity. So I can probably do another video on this. If anybody's still having trouble or have any questions, feel free to send me your questions, and I'll try to help you answer that. It is a little difficult, a little more difficult to understand, but this is kind of like one of the problems, like number one. There's easier ways of solving it. It's just accidentally coming upon it. So I hope this one helps. Well, let's see if I can get number 9 and 10 done about this time. Yeah, this is good. Okay. Yeah. Oh no, I've got a lot more time. That's good. If I need to, we can always go back and do that directly afterwards. But this next problem is number 9, and this problem says a 66-kilogram astronaut is stranded at a distance of 12 meters from a spaceship in free space. In order to get back to the ship, he throws a 50-kilogram piece of equipment with a speed of 4 meters per second directly away from the spaceship. How long will it take the astronaut to reach the ship?